Hello students, welcome to Pure Mathematical Academy. Today I am going to discuss a question of CSI and NET June 2024 and ये है part C का एक question. तो question क्या है? Question है calculus of variation का एक question and this question has only one correct option. Though it is a question of part C, but it has just only one correct option because you know here we have to find the infimum of the set and infimum will be a single real number. That's why any one of the options is correct. So how to proceed with this problem? I'll summarize the total problem at the last, but pehle I'm going to discuss the method of this problem. Firstly, you know this thing that is integration a to b root over 1 plus y dash square dt. ये क्या है? ये क्या है? जब भी हम लोग दोनों पॉइंट्स लेंगे, एक है a पॉइंट एंड और एक है b पॉइंट इन अ स्पेस, then the shortest path that joins these 2 points is called the infimum of this set. As we know from the physical interpretation of the problem, we know that whenever there are 2 points in a space A and B, in this type of problems, we can get that this would be a straight line. Now, analytically, how can we get it? We know that Euler-Lagrange equation, the very famous Euler-Lagrange equation है EL equation, let us call it as EL equation. EL equation कहते हैं कि del f del y minus ddx of del f del y dash equals to 0, right? तो यहाँ f क्या है? f है root over 1 plus y dash square. But see, there are some special cases of Euler-Lagrange equation, and we know that whenever the functional f is a functional depending only on the variable y dash, then we can have the special form that the extremal would be y equals to ax plus b. Now what is this? This is a straight line. This is a straight line. So we know in a two-dimensional space, whenever there are 2 points, like this is a two-dimensional space, whenever there are 2 points, if we join them by many curves, then the least distance covered to go from A to B is the curve that is straight line. We know from physical interpretation, so directly we could say it, but here by the analytical method, by the special type of Euler-Lagrange equation, we can get that the extremal is a straight line. So what are the initial points given? Initial points given here is y of a equals to a square and y of b equals to b minus 5. Now we know that if there is a straight line and if there are 2 endpoints, then how to calculate the distance between them? If a comma f of a is a point and if b comma f of b is another point, then what is the distance between them? The distance between them whenever they are joined by a straight line is b minus a whole square plus fb minus fa whole square, right? So here what are the values of fb and fa? Here fb is b minus 5 and fa is a square. So if we put this here, we get that b minus a whole square plus b minus 5, that is fb, minus a square, that is fa and whole square. Now if we extremize the function which is under the root. If we can extremize this part, then the total function, that is root over that, will be extremized, right? So let us call it as uh, f1, and f equals to b minus a whole square plus b minus 5 minus a square whole square. Now we have to minimize this function. Whenever there is a function of two variables, here there is this f is dependent on two variables, that is a and b. What we need to do? What we need to do? We need to extremize it. We need to find the critical points, that is fa equals to 0 and fb equals to 0. That is where at which points fa and fb का वैल्यू 0 होगा. तो इसलिए पहले fa निकलते हैं. fa क्या है? fa है माइनस 2b माइनस a माइनस 2a b minus 5 minus a square, right? And we have to put it as 0. Then we get that from here 2 and 2 is cancelled, so b minus a plus 2ab minus minus 10a minus 2a cube equals to 0, right? That is equals to b into 1 plus 2a equals to 2a cube plus 11a. We can write 1 plus 2a as the denominator, that is 1 plus 2a, right? So the expression of b is 2a cube plus 11a by 1 plus 2a from taking fa equals to 0. Now we will take fb equals to 0. Let us take fb equals to 0. Then if we take fb equals to 0, then 2 into b minus 5 minus a square plus 2 into b minus a equals to 0. So from here we can get that 2b equals to a plus a square plus 5, right? Now we will put this value in here. Then we can get 4a cube plus 22a by 1 plus 2a equals to a plus a square plus 5. Here comes calculation right now. There is no conceptual use till now, but there will be. A conceptual use of equation solving. And here it is a plus a square plus 5 plus 2a square plus 2a cube plus 10a. Right. So we get 2a cube a square plus a square 3a square, so 2a cube minus 3a square plus 11a plus 11a minus 5 equals to 0. So up to this we have to do nothing but calculations up to this point. But now there are some usage of concepts. See, this is an equation. This is an equation, right? This is an equation. We have to find the root of this equation. This is a 3-degree polynomial. So there will be 3 roots. You can see that by Descartes' rule, Descartes' change of sign rule, we can see there is one root change, there is one sign change, there is the second sign change, and there is the third sign change, right? So we can get 3 or 1, 3 or 1 positive real roots. And what about negative? If we put a equals to minus a, then we can get minus 2a cube, minus 3a squared, minus 11a, minus 5. That is, there is no sign change. So, there is zero negative real root. Now, let us put a equals to 0. Okay, let us put a equals to 0. We know that we will get 3 or 1 positive real root, but let us start with a equals to 0. If we put a equals to 0, so if we put a equals to 0 in this equation, we can get the value is minus 5, that is less than 0. Now if we put a equals to 1, we get 2 minus 3 plus 11 minus 5, that is 13 minus 8, that is 5, that is greater than 0. So we are sure about one thing, that between 0 and 1 there lies at least one positive real root, right? So by numerical bisection method we can get, let us take a equals to 0 plus 1 by 2, that is a equals to half. Now we are going to put the value of a in the equation, that is 2 into half cube minus 3 into half square plus 11 by 2 minus 5, that is 2 into 1 by 8, that is 1 by 4 minus 3 by 4 plus 11 minus 10, that is 1 by 2, and from here we can get minus 1 by 2 plus 1 by 2, that is equals to 0. So we see here that by numerical bisection method we get that a equals to half is a root of this equation. Now the thing to observe is that whenever we are taking the values of a greater than half, it is increasing strictly and monotonically. We can see it by putting some values, a equals to 1, a equals to 2, a equals to like zero point 0.9, and whenever we are putting something where a is less than 0 and greater than when a is less than half and greater than 0, that is when the value of a lies between 0 to half, then we can see that whenever it is going away from half, the more negative it is going to be. So we can get a clear idea that a equals to half is the only one real root of this equation, because there is no negative real root. So the cases where a less than 0 is nothing of importance, right? So we can get that a equals to half is the only real root of this equation. Now we may check by taking the Hessian matrix. What is Hessian matrix? Hessian matrix H equals to I of AA, I of AB, I of BA, I of BB, right? Where I is this equation, where this equation is, we can call it as I. So we can check this Hessian matrix, and after checking we can see that at a equals to half we will get a minimizer here, not a maximizer. But you see, as there is only one point, that is a equals to half, where the value of a where the value of the equation is got extremized. So it is quite clear that it will give us the minimum value, right? Because in the question the minimum value of the set was asked. So let us put this a equals to half and get the expression of b. That we know that 2b equals to 5 plus a plus a square. That is 5 plus half plus 1 by 4. So 4 is 20 plus 2 plus 1. That is 23 by 4. And from here we can get the value of b equals to 23 by 8. So what are the values? What are the values here? At half comma 23 by 8 we get the value of y half equals to, what was ya? Ya was a square, that is y half equals to 1 by 4. Y 23 by 8 equals to b minus 5, that is 23 by 8 minus 5, right? Now we have to find the distance, that is root over 23 by 8 minus half square plus 23 by 8 minus 5 minus 1 by 4 whole square. We have to find this value because this will give the shortest distance, right? So after calculating, what can we get? We get 8 and 23 minus 4, that is 19. 19 by 8 whole square plus, here we can get 23 minus 40 minus 2, that is root over 19 square plus 19 square by 8 square. So 19 root 2 by 8. Okay, so we have find the shortest distance. We have found the shortest distance as 19 root 2 by 8. So this is the whole procedure of this problem. This problem is quite long and I can't say that this is a very easy problem. So 19 root 2 by 8, option A is correct. So let us summarize what we have got. First of all, see, by the special type of Euler-Lagrange equation, we got that the extremizing function is the straight line, that is y equals to x plus b. Then we know how to find the distance between 2 points when they are connected by a straight line. That is root over fb minus fa whole square plus b minus a whole square. Now we have the value of fb and fa. We have put the value of fb and fa here and we got the f1. Now we know that root over something is got extremized when that something part is extremized, right? So we have taken the value that is inside the bracket, sorry, inside the root over, and we have taken the first partial derivative with respect to a and the first partial derivative with respect to b, and we set it as 0. Then from there we got the value of b and a by using Descartes' rule of sign. We got the value and using numerical bisection method we have found the root of which value the a and b we can get the extremizer. We have put the values a and b in the equation. We got the initial condition. We have found fa, we have found the fb, we have found a, we have found b, and then we have used the formula for calculating the distance between 2 points when they are joined by a straight line, and we have got the result. So to say, this is not a very I mean, there is nothing very conceptual, there is no conceptual complexities, right? But there is calculations which can disturb me to do this problem in a short time. So uh, for this problem, you may need some time to do it correctly, right? So this is the process of this problem, and that's it for today. Thank you.